Hi everyone, I am Reshma, Assistant Professor, PG Department of Mathematics from E-Content Development Center, Majlis Arts and Science College, Puramannur. Today I am going to take the topic rate of change. After studying this topic, you will be able to understand what is rate of change and types of rate of change. The learning objectives are to understand the rate of change and different types of rate of change and to know the applications of rate of change in the field of economics. Now, what is rate of change? Rate of change is defined as if the variable y changes proportionally with respect to x, then y is related to x by a linear equation y is equal to mx plus, where m is delta y by delta x. Here m is called rate of change of y with respect to x and delta x. Some examples of rate. A physician may want to know how small changes in dosage can affect the body's response to a drug. Another example is an economist may want to study how investment changes with respect to variations in interest rate. That is, a rate of change is applied in many fields. Here we have a problem. The problem is the price of electricity changes proportionally with the time if the price goes from 2 cents per kilowatt hour per kilowatt hour in 1984. What is the rate of change of price with respect to time and what will be the price in 1991? And the answer is, here we first denote P as price of electricity in cents per kilowatt hour and T denote time in years. So, first the price goes from 2 cents to 3 cents. Therefore, delta P equal to 3.2 minus 2, it is equal to 1.2. And change in time delta T is equal to 1984 minus 1982, it is equal to 2 years. Hence, the rate of change of price with the time equal to delta P by delta T is equal to 1.2 divided by 2 equal to 0.6 cents per kilowatt per hour per year. Since P changes proportionally with the time and the rate of change of P with respect to T is 0.6. Therefore, the equation relating P to T is P equal to 0.6 T plus C, where C is a constant, it must be determined. Given P equal to 2 when T equal to 1982. So, we substitute this P and T in equation number 1, we get C equal to minus 1187.2. Hence, the equation relating to P to T is P equal to 0.6 T minus 1187.2. And we have another question. When T equal to 1991, we get P equal to 7.4 and the problem is solved. Here, this problem is an example of rate of change. Here, we have to study the types of rate of change and there are two types of rate of change. One is average rate of change and another is instantaneous rate of change. And first one, average rate of change. What is average rate of change? If the dependence of y equal to f of x is not linear, let L delta x be a small change in x and delta y be the corresponding change in y, then delta y by delta x is equal to f of x naught plus delta x minus f of x naught divided by delta x is called average rate of change. And another type is instantaneous rate of change. Instantaneous rate of change is equal to delta y by delta x is equal to limit delta x tends to 0 f of x naught plus delta x minus f of x naught divided by delta x. And we have a problem. An oil slick has an area y is equal to 30x cube plus 100x square meters x minutes after a tanker explosion. Find the average rate of change in area with respect to time during the period from x is equal to 2 to x is equal to 3 and from x is equal to 2 to x is equal to 2.1. And we have another problem. What is the instantaneous rate of change of area with respect to time at x is equal to 2? So, in this problem, we have two questions. One is to find average rate of change and another is instantaneous rate of change. First one, average rate of change. Here we have given y is equal to f of x is equal to 30x cube plus 100x. So, the average rate of change from x is equal to 2 to x is equal to 3, that is when x naught is equal to 2 and x naught plus delta x is equal to 3. Therefore, average rate of change delta y by delta x is equal to, we know the equation f of x naught plus delta x minus f of x naught divided by delta x. It is equal to f of 3 minus f of 2 divided by 3 minus 2. So, f of 3 is, we put x is equal to 3 in equation y equal to f of x, and f of 2 is, we put x is equal to 2 in y is equal to f of x. Therefore, we get the answer 670 square meters per minute. And similarly, the average rate of change from x is equal to 2 to x is equal to 2.1, we done the similar method. That is delta y by delta x is equal to f of 2.1 minus f of 2 divided by 2.1 minus 2, and we get the answer 478.3 square meter per minute. So, the first question is solved. Find the average rate of change. And we have another question. What is instantaneous rate of change? So, instantaneous rate of change we use at x is equal to 2, we find f dash of 2. That is f dash of 2 equal to, we already have a formula y is equal to f of x is equal to 30x cube plus 100x. First, we find the derivative of f of x. That is f dash of x is equal to 90x square plus 100. Then we put x is equal to 2 in f dash of x. Therefore, we get f dash of 2 equal to 460 square meters per minute. So, after doing this problem, we have to know about how to solve average rate of change and instantaneous rate of change. Instantaneous rate of change is very simple. It just determine first derivative and put x is equal to 2 in that. We have another problem, problem number 2. The problem is, volume of a cone is 1 by 3 into area of base into height. We already know about volume of a cone, and if the base has radius always equal to the height, find the rate of change of volume with respect to this radius. So, we have to find rate of change. First, let me denote V equal to volume of cone. So, we have the formula V equal to 1 by 3 into area of base into height. Therefore, we know a base is circle. Therefore, area of base is pi r square. Therefore, volume of cone is equal to 1 by 3 into pi r square into h. Already given that height is equal to radius. Therefore, we get 1 by 3 into pi r into r. It is equal to 1 by 3 pi r cube. So, we have to find rate of change of volume with respect to base radius. So, we have the formula dV by dr. dV by dr is equal to d by dr of 1 by 3 pi r cube. We know the derivative. Therefore, dV by dr is equal to pi r square. It's a simple problem. The volume of cone is already we know that. Therefore, rate of change is equal to pi r square. Here, there are some applications of rate of change in the field of economics. In economics, there are mainly used some applications of rate of change. First application is productivity of labor. Here, first we imagine a factory in which X worker per hours of labor can produce Y is equal to F of X rupees worth of output. First, suppose that y changes proportionally with x. Then delta y is equal to f of x naught plus delta x minus f of x naught represent the amount of extra output produced if delta x extra worker per hours of labor are employed. Thus, Delta Y by delta X is the output per worker hour. The average rate of change is called productivity of labor. In productivity of labor, we use rate of change. And next, suppose that f of x is not linear, then delta y by delta x is the extra output per extra worker, hour of extra labor when delta x extra worker per hours of labor are employed. This limiting value as delta x becomes very small is f dash of x naught, and this instantaneous rate of change is called marginal productivity of labor. That is, in field of economics, we call average rate of change as productivity of labor and instantaneous rate of change as marginal productivity of labor. And the problem is, a bag factory produces 30x minus 2x square minus 2 rupees worth bags for each x worker hours of labor. Find the marginal productivity and when 5 workers are employed. So we have to find marginal productivity, that is instantaneous rate of change. So we already know that how to solve instantaneous rate of change. We find derivative of f of x. So we have f of x is equal to 30x minus 2x square minus 2. Therefore, f dash of x is equal to 30 minus 4x. So just substitute x is equal to 5 in f dash of x. That is, f dash of 5 is equal to 10 rupees per worker hour. The last section is here. You have to solve 2 problems about rate of change, and one problem is a balloon being blown up has a volume V equal to 3t³ plus 8t square plus 16t cubic centimeters. After t minutes, what is the rate of change of volume at t equal to 0.5? So you must use the equation of volume and find the rate of change of volume. And the second question is, a shoe repair shop can produce 20x minus x square minus 3 rupees of revenue when x worker hours of labor are used. Find the marginal productivity in rupees when 5 workers are employed. Here we have to find instantaneous rate of change. So I hope you all understand about what is rate of change and types of rate of change and applications of rate of change. Anyway, thank you.